Victory class, we are going to look at section 7.5 notes, unit circle approach to trigonometry. So the unit circle is just a circle centered at the origin of radius 1. So you can see the origin is the center, -1, +1, all the way around. That's the radius of this circle. And the way the unit circle approach goes is the cosine of the angle is going to be our x-coordinate of the point that we rotate to on the circle, and the sine of that angle is the y-coordinate of the point we rotate to. So I'm just going to make A is what I'm using as the angle here. Theta is the kind of the standard that we use to label an angle. But if I rotate here at any point and just stop, you can see theta represent the angle that we have rotated to, and the cosine of theta is the x-coordinate of that point. The sine of theta is the y-coordinate of that point. So if I just, for instance, I'm taking away the label sine and cosine, if I just put a checkbox, there's the actual numbers. So those are 2 points that are on this circle, and so the cosine of 1.14, that's my angle measure in radians, you can see is 0.41759, which is that x-coordinate. And then the sine of the angle that I've rotated to right now is the y-coordinate. So I can just change this to A, and it'll be a slider. And you can see now as this rotates, there's -0.556. That is the cosine of this angle. The sine is that, okay? A can be, you can put in those special angles like we saw in the previous chapters. So pi/6, and there's that √3/2 and 1/2. All right, I could do pi/4. Right, so there's the things that we saw before, and we're seeing it. These are just points on the unit circle. These special numbers that I encourage you to learn those decimals. They are just points on a circle of radius 1. All right, so there are the objectives of this section. Similar to some of the other objectives, but specifically we're using the unit circle to arrive at these objectives now. That's the big difference. All right, so just like we were saying, if P is some point on the unit circle AB, then the y-coordinate of that angle that we've rotated from standard position is the sine of that angle, and the x-coordinate that we've rotated from that standard position is the cosine of that angle. All right, the tangent function, B/A, that's the y-coordinate divided by the x-coordinate. Well, the y-coordinate was sine, the x-coordinate was cosine, so that's saying tangent is sine over cosine again, like we've seen before. Cosecant is 1/b. B was the y-coordinate. It's 1 over sine. It's the reciprocal of sine, reciprocal of cosine for secant. That's the same thing that we saw in the last section. It's just, again, we're applying it to the unit circle now. All right, tangent, and in particular, you can see it on the unit circle just as well as you can see the sine and the cosine. The sine and the cosine of those points. Tangent is the slope of this line, right? Because tangent is the y-coordinate divided by the x-coordinate. Well, this other point down here is the origin. And if you recall, the slope between 2 points is y2 minus y1. So this y-coordinate minus 0 divided by x2 minus x1. This x-coordinate minus 0, which is just this y-coordinate over this x-coordinate, is the slope of this little line segment. So cosine is the x-coordinate, sine is the y-coordinate, and tangent is the slope of this line segment. So I can see this is a positive sloping line because it's rising as I move left to right, so it's a positive value. So tangent is equal to 1 right now at this point. Rise and run, you can see I'm going through the center of this square, all the little squares on the grid marks. So that's that 1-to-1 ratio. Right, but if I increase the value A, and I've got to change it from pi/4 to some other number, now I can get my slider back and I can make this change, and you can see we'll get changing values of tangent as well. All right, so I'm increasing. You can see when I get to pi/2, it changes. The sign changes for the cosine, it becomes negative. And because the y-coordinate is positive, it's still above, tangent becomes negative. But again, you can see it. That's a negative sloping line. So tangent is negative now. Rotate into quadrant 3. Now both x and y are negative, but a negative divided by negative is a positive. Tangent is positive again because this is now a positive sloping line. And then finally in quadrant 4, x is positive but y is negative. So therefore tangent y divided by x is going to be negative. All right, so find the values of sine, cosine, tangent, all these different things if p is negative 3, square root of 3 over 2 and negative a half. So that's our point. The x coordinate on the unit circle is cosine, so cosine is equal to this negative square root of 3 over 2. Sine is the y coordinate. Right? Tangent is the ratio that what we get if we divide the y coordinate by the x coordinate. So negative 1/2 divided by negative 1 over the square root of 3. Negative square root of 3 over 2. But remember, when we divide fractions like this, done easiest by flipping and multiplying. So the 2's cancel. Negative times a negative is a positive. This is 1 over the square root of 3, which simplifies if we rationalize the denominator. The square root of 3 over 3. Right, so there is tangent. And then the other three, remember, are the reciprocals of these. So cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. Cotangent is the reciprocal of tangent. So now I'm going to flip these over. Flipping over negative a half gives me negative 2. Flipping this over initially gives me 2 over the square root of 3. But remember, we flip that and rationalize that denominator. Okay, and then the same thing with tangent. So instead of negative square root of 3 over 3, we flip that, we'll get square root of 3. All right, there are the definitions of sine and cosine, tangent, all the 6 trig functions in terms of a point coordinates, the x coordinate, the y coordinate, and then r, where r is the distance that point is from the origin. And I'm not really thrilled about how the book does this, like switches between x and y and a and b. If this was the notation, then this would just be x and y, and everywhere we saw a b, we would replace it with y. Everywhere we saw an a, we would replace it with an x. That's kind of the more standard way people see this, is to have x and y in there where you see the a and the b. But anyway, that's the unit circle approach. Again, it's just points on the unit circle can easily define the 6 trig functions. All right, and then we can extend that just like we did in the last section. We can extend that if we went beyond a unit circle or circle to any radius. I can tell that this is not a unit circle anymore because both of these numbers, the x coordinate and the y coordinate, are both bigger than 1. So that can't be on the unit circle. But I can do the same math that I did, square the x, square the y, add them together, take the square root, and find what the radius of that circle that they live on is. So I got a circle of radius 5, and then I can plot that, and again find all the 6 trig functions of this particular point, negative 3, 4. All right, I do want you to see in your in Desmos. Again, you're not going to be allowed to use Desmos on the test, but I want you to see just this in Desmos because we're going to eventually get here where we're doing these types of plots. But notice this says r equals, some math is done, and then ultimately it's 5. So the equation, if you just kind of look at the beginning and the end, is r equals 5. And in Desmos, if you just type r equals 5, zoom out for you, that is a circle of radius 5. I'm turning it on and off so you can see that's the graph that we're looking at. Make sure this over so you can see how to turn on and off graphs. That's a circle of radius 5. Literally, r means radius. Radius equals 5, and Desmos will give you a graph of a circle. Okay, and r, the radius of a circle that has a particular point on it, can be found just by doing that to the point. Squaring the x coordinate, squaring the y coordinate, adding, taking the square root, and you've got radius of a circle centered at the origin that would contain this point. All right, so just like we saw in the previous section, once we know r, once we know the radius of the circle that we live on, we can find all 6 trig functions. All right, the domain and range of the trig functions. That comes from understanding what would happen with these different ratios that we get. So sine and cosine, they are the x and y coordinates of the point on this circle. So let me take away the r equals 5 and go back to our unit circle. So literally, sine and cosine can be defined by this circle. They're the x and y coordinates of the points on the circle. Well, you can see that as I rotate around, I'm starting off at positive 1 for x, or the cosine. And as I rotate around, these points start to shrink from positive 1 down towards, there's 0. We're crossing over 0 for the x-coordinate. And now we're making our way towards the negatives, and we peak at -1. That's as far to the left as we go. And then we start to rise in the x direction. We start to increase our x's again until we're back to where we started. So the cosine function, I stopped at 2 pi, but I could keep going around forever and ever and ever if I wanted to, and just keep going around this circle over and over and over and over and over. It would just never stop. But the x coordinates would never get past +1, and they would never go past -1. But it would be every x coordinate in between. So the domain of cosine is all real numbers. I can plug in any angle, right? Because cosine is the x coordinate determined by the angle that we've rotated off the x-axis. I can rotate by any angle. I can just keep rotating in the positive or negative direction. Again, I'm stopping at 0 here, but I can do like -20 pi in that direction as well. And I'm just rotating in the other direction, but I'm going to always be able to get points on this circle. So there is no limit to what can go into cosine, but what can come out is limited. I can go down to -1, I can come up to +1, and anything in between, but nothing on the outside of those. So the domain of cosine is all real numbers. The range is -1 to 1. The same thing's going to happen for sine. All real numbers can go in, but only 1 and -1 can come out. Now, because all of the others are determined by fractions that contain either the x or y coordinates in the denominator, we have to think about possibly dividing by 0, right, if any of these things are 0. All right, so A is cosine. Well, when cosine is 0, that means the x-coordinate is 0. That means we're up here on the positive y-axis, or the negative y-axis. We're on the y-axis, period. And that happens at pi/2. It also happens at -pi/2, or 3pi/2. Right? It also would happen again at 5pi/2. If we rotated all the way around, we would get back all the way to the y-axis again. And if you notice, it's 1pi/2, we're on the x-axis. 3pi/2, we're on the 1pi/2, we're on the y-axis. 3pi/2, we're back to the y-axis. 5pi/2, we're back to the y-axis again. 7pi/2, the negative y-axis. And those are odd multiples of pi/2. Right? And those are the places where cosine would be 0. The x-coordinate is 0. Those are the odd multiples of pi/2. Well, why is that important? Because that's where we would divide by 0 when a is in the denominator. Those odd multiples of pi/2. So that's why you see the domain of the tangent function is a set of all real numbers except the odd multiples of pi/2. Likewise, when we switch and do b being in the denominator, or the y-coordinate being in the denominator, that happens when we're on the x-axis, which was the original value, right? When we started off, we're on the x-axis. The y-coordinate was 0. And then when we rotate all around to pi, we're back to the y-coordinate being 0. And then all the way back around to 2 pi, the y-coordinate is 0. So now the multiples of pi are going to be what makes sine equal 0. And so that's why you see the odd, that's secant function. Secant, yeah, it's 1 over cosine as well. So that's the odd multiples of pi/2 as well. So anything that has cosine in the denominator, which is tangent and secant, will have that as its domain restrictions. Anything that has sine in the denominator, which is cotangent and cosecant, those are just the multiples of pi. All right, now we're looking at the range of these trig functions. So the range is what they can output. This is like the y-coordinates. So again, it's something you really want to have down. Sine and cosine can only output numbers between -1 and 1. Right? Secant and cosecant, because they're the reciprocals. Right? Like numbers between -1 and 1 would be like 7/8, -5/6, square root of 3/2. Numbers where the numerator is smaller than the denominator. So therefore, if you flip those over, you get 8/7 and 6/5 and 3 over the square root of 2. You get numbers that are bigger in the numerator than the denominator, which are improper fractions. And so you end up with numbers that are in absolute value larger than 1, which means below -1 or above +1. All right, and then this is also very important, especially with tangent. Output of tangent and therefore cotangent is all real numbers. Right? The tangent function will go off and to infinity and negative infinity. Secant and cosecant will as well. They'll go off to infinity and negative infinity. The big difference is tangent can be 0. Cotangent can be 0. They can be between -1 and 1, where the secant and cosecant cannot. But just understanding these are the ranges. These are the ranges of these trig functions. So this is the idea that because 2 pi radians is 360 degrees, if we are at some angle and we rotate, like adding to that is rotating, we add 2 pi, and k is a whole number like 1, 2, 3, 4, or possibly -1, 2, 3, 4. If we add or subtract 2 pi, a full rotation, then we're right back to where we started. So this is saying the y-coordinate, let's start over on this side, the y-coordinate at some angle, so there's our y-coordinate, at some angle, would be the same as, would be the same as the y-coordinate if we rotated all the way around multiple times. That k is some number. So again, just think about it. You're standing in some room and you're facing a certain direction, right? And you're pointing maybe, right? And then you turn all the way around. Well, you're going to be pointing in the exact same spot. And if you turn around over and over and over again, you're going to be pointing in the exact same spot. That's the same. That's what this is basically saying. Periodic just means you get back to where you started. And because these are points, cosine the x-coordinates of those points and sine the y-coordinates of those points, we end up back where we started if we rotate 2 pi or 360 degrees over and over again. So there's what that looks like in function notation. All right, some periodic function f, if we start at some input, some value, we'll get right back to the exact same output if we add that periodic value to it. Okay, so for sine and cosine, the initial angle can be anything, and that value of p would be 2 pi, or again, 360 degrees. That would get us right back to the same exact output that we started with. Now notice the periodic values for sine, cosine, secant, and cosecant are always 2 pi, but for tangent and cotangent it is just pi. And you may think that that's bizarre, but again, if you go back and think about our definition, tangent is the slope of this line. Well, if I rotate 180 degrees from where I was, I would be down here somewhere, right? That's 180 degrees or pi radians. And now I'm on that same line that I was before. So it would have the same slope. Therefore, the tangent would be the same. And then if I rotated again 180 degrees or pi radians, I would be right back to that line that I started on and in the same quadrant. So the slope would be the same because I'm literally right back to where I started. But the difference is at half a rotation, we're back to a slope, a line segment whose slope is equal to the slope it was before. So therefore it is the same output of the tangent function. And again, therefore, because cotangent is just the reciprocal of tangent, it would happen, this period of pi would happen for cotangent as well. So the big thing there, just remember, all the trig functions, all four sine, cosine, secant, cosecant, have a period of 2 pi, but tangent and cotangent specifically have a period of. All right, find the exact values. Again, we saw how to do this in the last slide. We can use the known values that are between 0 and 2 pi radians, or 0 and 360 degrees, by shrinking these down to those numbers to being in those range. So 765, if I subtract 360, I'm still bigger than 360. So if I subtract 360 again, you can see that I'm at 45. And so that means the sine of 765 degrees is the same as the sine of 45 degrees. The y-coordinate at 765 degrees is the same as the y-coordinate at 45 degrees. And since we've seen the sine of 45 in previous sections, we've seen it, but we maybe don't have it memorized yet. But we should start to get to know that that's going to be the square root of 2 over 2. All right, don't forget, your calculator can do this. Switch your mode to degree mode, second mode to quit, sine of 45 degrees. Maybe I don't recognize that, so I'm going to type the square root of 3 over 2 to see if that's the number. That's not it, so I'm going to do it again. Watch this. I can do second. Let me move this up a little bit so you can see. I can press second, enter. If I bring back the last thing I did, I can change that 3 to a 2, and now I see that that is the value that I got before. All right, remember the things to check are, 1/2, square root of 2 over 2, square root of 3 over 2, 1, 0, all those different values. So check those when you type the number in and you get this decimal. Check those special values that we keep getting, we keep seeing in this course, and see which ones match up. All right, remember for the radian measures like 25 pi over 4, ignore the pi. So I'm just going to type 25 fourths. All right, when I hit enter, I see that number is much bigger than 2. So that means it's bigger than 2 pi. Remember, we took the pi away. So that's bigger than 2 pi. So I'm going to subtract. You can do subtract 2, but when you know it's going to be bigger than 2 when you subtract, you can just keep subtracting. So I could subtract 6 here and get to 0.25. That is the same as a quarter. So that means that this is coterminal with pi over 4. So there's the tangent of pi over 4 is equal to the tangent of this. Tangent of pi over 4, again, that's a special angle. That was equal to 1. You can start putting that to memory. But I could also just do tangent. Let me switch my mode back to radian mode. 25 pi over 4 is equal to 1. So you could always check it with that TI calculator. All right, 11 pi over 3. Again, I'm going to take away the pi. So 11 thirds. Hit enter. That's bigger than 1, or sorry, bigger than 2. So subtract 2. That's no longer bigger than 2. So that's the one I want. So math. Change it back into a fraction. It's 5 thirds. So that's 5 pi over 3. So there's the cosine of 5 pi over 3. That should be a number that we are familiar with. All right. If not, you can type it into your calculator and you'll easily see that. You'll recognize that decimal. That's negative 0.5. All right. Even odd properties of functions mean that they're symmetric either at the y-axis if it's even, or symmetric at the origin if it's odd. So if you're looking at these, if putting a negative input into a function gives you the opposite of the original function, like it does for cosecant, sine, tangent, and cotangent, those are all odd functions. If you put in a negative input and you get the same thing that you got before you change the input to its opposite, then that's what we call an even function. And cosine and secant are even functions. So what does this tell me? It changes the rotation, basically. So basically what this says is if I start rotating from standard position, so there's my positive x-axis. If this would be positive theta. I'm rotating in that counterclockwise position. Well, negative theta would mean go the exact same angle, but in this direction, in the negative direction. Okay. Now, sine is the y-coordinate. Y is up and down. Obviously, if I'm rotating upward, clockwise versus downward from the x-axis, then I get the opposite sign. And that's what this is literally saying. The y-coordinate, that sine, that you would get by rotating clockwise versus counterclockwise is the opposite of the y-coordinate you would get if you rotated counterclockwise. Sine is y-coordinate. Look at cosine. Cosine is the x-coordinate. Think about a point. If I rotate here, that xy, well, that x-coordinate, if I drop down to the x-axis, is going to be the same as the x-coordinate if I rotated down to this direction. So if I rotate in the opposite direction, the x-coordinate is the exact same as the x-coordinate if I rotated counterclockwise. All right, and then finally remember, tangent is like the slope. So if I rotated positively upward like that, the slope of this line is a positive slope. But if I rotated clockwise, that same amount, I would get a negative sloping line. And it would be sloped by the exact same amount, but just negative. So the slope, if I rotate clockwise, is equal to the opposite of the slope if I rotate counterclockwise. So that's the way I think through the even and odd properties. Right? Even means we get the exact same thing no matter which way we rotate. Odd means we get opposites. So there is just this being applied with those negative angles. Just notice sine, cotangent, tangent. We're changing from positive sine to negative sine. Right? The angle's changing signs, but so is the sine function. Right? For cosine, we're just dropping the negative sign because it's an even function. Cotangent, again, there's the negative. Think of it like the negatives like coming out to the outside, if you will. And the same with tangent. Tangent is an odd function, so that negative comes out and becomes a negative tangent. Right, and then they're doing the coterminal property there again, just to get it down to smaller numbers. Right, don't forget your calculator can help with basically all of this stuff. Just make sure you're in the right mode. Right, so the sign of negative, remember negative is not minus. So you're not going to use this one, you're going to use the one below the 3 button. So it's sign of negative 30. I'm going to do, instead of switching to degree mode, I'm just going to go to the angle menu and choose degree. Alright, so there's the sign of negative 30, and you can see it's negative a half. So again, your calculator can help with a lot of this stuff. Right, a lot of these can come straight from points on the unit circle. You can, and I would strongly encourage you guys to do this. I'll put one on our Moodle page too, but you can just Google search unit circle, and there are so many images online that you can find this. But if I use this, for my example, there's pi over 6, pi over 4, pi over 3. Cosine is the x-coordinate. So the cosine of pi over 6 is the square root of 3 over 2. The sine of pi over 6 is a half. There's 135 degrees. The cosine of 135 degrees is the x-coordinate. Negative square root of 2 over 2. The sine of 135 degrees is positive square root of 2 over 2. So the unit circle is a great tool for helping you memorize these values. I want to show you this in addition to that. This is a way to help you memorize the unit circle. Look at the numbers. 1, square root of 3 over 2, square root of 2 over 2, 1 half, and 0. And if you look, that's my x-coordinates, right? Well, these are all the exact same. They're just negative. These are all the exact same. They're just negative. These are all the exact same. They're just positive. They are the exact same. But here's even further than that. Check this out. This is how it's going to make it not quite so bad to memorize this. All right, 1. Think about it. 1 is the same thing as the square root of 4, which is 2, divided by 2. So 1 is the square root of 4 over 2. And then this is the square root of 3 over 2, square root of 2 over 2, and then 1 half. But 1 half is the square root of 1 is 1, the square root of 1 over 2, and then 0 itself is its own square root as well. So the square root of 0 over 2. And if you look, that is all of these numbers. The square root of 4 over 2 is 1. Square root of 3 over 2. Square root of 2 over 2. The square root of 1 over 2 is a half. The square root of 0 over 2 is 0. And that literally is all of those x-coordinates everywhere around the unit circle, other than the sign. How do I get the signs right? Well, just flip them over. It's symmetry. Right, there is 1 half for the x-coordinate. Flip it over the x-axis. There's negative a half. I flipped over the x-axis. I went from positives to negatives. So the x's changed signs, but their values stayed the exact same because of that symmetry. It's a circle, so the x-coordinates are perfectly symmetric. All right, but the crazy thing is, again, if you look at it, that's also the y-coordinates. 0, 1 half, square root of 2 over 2, square root of 3 over 2, 1. It's the exact same thing. It's the square root of 0 over 2, the square root of 1 over 2, the square root of 2 over 2, the square root of 3 over 2, square root of 4 over 2. It's just one is shrinking and one is growing as the angle grows. And then it's all just symmetry to get the signs and the correct coordinates. So those are the things those are little tricks that will help you memorize the unit circle and therefore understand the sine, cosine, tangent, all that from the special angles. Right. In addition to this, I would put the special values for cosine, like find yourself a unit circle, print it out, and add to it the tangents. Right. So at this angle is 0 degrees, tangent is 0. At pi over 6, right, it's y over x. It's 1. It's just the numerators. 1 divided by the square root of 3, which is the square root of 3 over 3. All right, pi over 4, the tangent is equal to 1 because the x and y coordinates are equal. And then here it is 1 the y coordinate square root of 3 over 1. That, again, numerator divided by numerator for the point. So it's just the square root of 3. And then 1 divided by 0, you can't divide by 0. So this is an undefined slope. I'm just going to put UND for undefined. And again, there it is. That's all the values for tangent and cotangent. It's just going to reverse for cotangent. So for cotangent, this one will be undefined. For cotangent, the square root of 3 and the square root of 3 over 3 will switch places. Right? Cotangent and tangent of pi over 4 are both 1. And then for cotangent, this will be 0 instead of undefined. So it's, again, you can memorize the unit circle, all the values on it, or you can memorize that first quadrant and use symmetry to get all the other values. Right, and that is what they're showing you on these last examples. It's just how to use the unit circle and the values on the unit circle to be able to find the points and apply those to the sines and the cosines, along with their signs, plus and minus signs, and that will make it so much easier to evaluate these things, is to use a unit circle to help you initially.